we're talking about making simple sequencers in Max. And I encourage you to follow along. You can also take notes in the method that suits you best if you like doing text or drawing or things like that. You can also like do this in Max along with me and then screenshot it, however you want to preserve this work. So let's recall the design we had for the very absolute simple one we had in our last class. And in that example, we made, can anyone remember what that was? Anyone wish to chime in? We made a sequencer, but we made it with a number of certain objects, right? And so the objects that we had were, anyone want to recall? We had a toggle, T for toggle, and I'll make it bigger so we can see. We had a toggle. What was another object we had? Yeah, we definitely had bangs. So what I'm gonna do is I'm gonna make the things and then just kind of like, okay, we had a toggle, we had a bang. What else did we have? Something that keeps time. We had a metronome. Object name is metro. Yep. Huh? I'm sorry, say the first part of what you said. Not a float. Not a float. You're close. You're close. A float is a different dog. It starts with an I. Anyone want to help? Integer. It's an integer. Yes, we had integers, and we can actually make one with a hotkey just by pressing I. P.S. I went a little quick. I'm sorry. With the bang, you can literally just press B, and it'll just make tons of buttons. See, now we have like a measles outbreak. Okay, that's not funny at all. So, integer. Float does exist. We don't need it for this assignment, but you can just hit F, and you'll notice it has a little decimal point. Anyway, that does exist in Max, and we don't really need that one, so we're going to throw it over here. It's gone. What else do we need? We need something to keep track, something to count. We could call it a counter. Yes, we had a counter, and then we had something to select for those numbers, object called select. Okay, is this starting to kind of, okay, try remembering this? Okay, let's set up our regular counting device. So I'm gonna move the metro over here. By the way, I could just plug it in wherever I want to. Like I could put the metro over here and plug it in and it'd still work just fine. I like to kind of perhaps think vertically in Max. So I have a toggle, it's gonna turn on the metro, that's right. And then it's going to trigger a bang. So I'll make another bang. Metro plugs into the bang, boom, there it is. And remember how we changed the argument for metro? I want this to be flexible, so I'm gonna take my integer object, drag it over here, plug its output into the input of the metro, the cold input, right? And then put in some kind of integer of my choosing. Great. Let's test it. Let's test this device. I'll make the bang a bit bigger so we can see it. Good, it's working. If yours is not behaving the way you expect it to, double check that your connections are going to the right place. Okay, so that works. Now, we need to keep count of those. Yep. So the counter is going to accept the bangs coming through, right? And then it's going to display for us an integer. And by the way, if I'm going quickly, it's because there's a bit of ground I wish to cover today. So bear with me. Counter, notice the first outlet, first as in furthest to the left, right? Says current count, and we plug in the current count to our integer box. And then we hit this, and it's just going to count into, well, kind of virtual infinity. Not really infinity. Not really. there's a certain point where there'd be too many digits and the computer's memory would give up, but that would take a long time, a very long time. So we need to add and append an argument to counter. Well, let me back up here. What kind of argument do we need for counter? We need a number. We need a number. We need a range of numbers. I'm going to put 1 space 8. And then when I restart my counter, when I restart my metronome to the counter, notice it's going to cycle from 1 up to 8. Okay. Hopefully yours is operating like mine. Hooray. Okay, pretty basic. Yay. Now, we need to use the select. And we're going to plug the integer into select. Can you guess what select is going to need? Just like counter had? It's going to need not just one number, but a series of numbers. It needs an argument that is going to tell us what is it listening for. Now, at the risk of being a little confusing, let me back up for a second. In Max, every object has its own arguments that it wants to accept or not. In the case of counter is coded and written in the background of Max to expect an argument in this style with a couple numbers, and then it interprets what those numbers mean. In the case of select, well, it can accept almost anything. Look, it even says that. Selectors. Anything. Anything? Anything. Well, it's not going to bang. Here, let me put a bang at the end of that. Let's see. This is bang if input matches anything. Wait a minute. I thought we said anything. It's not banging. What? What's happening? It's because select is listening for a message that says anything. It's expecting that string of characters. Anything. Anything. And see, when I click on anything as a message that I'm sending into select, it'll send the bang. But what if I have Charlie Parker? I want quotes. This is just for instance. Will it bang if I hit Charlie Parker? Nope. Tragic. Okay, so that means that it's listening for some kind of symbol that could be a string of text, or in our case, it's going to be integers. And which integers are we working with right now? Shout them from the rooftops. 1 through 8. Yes. So we need to go 1, 2, 3, 4. Oops. It's the peril of switching keyboards. Yep. Those are the symbols that it is listening for. Okay, I want to pause here and ask, are there any questions so far about this bizarre little device we've created? Oh, yeah, when I did that, which you don't need to do, but when I did that, that object is a message box, and you just hit M. Yep. A message box is an object that can act like a button if the patcher is locked. And you can lock the patcher and then click on it, and yeah. Okay. All right, this is making sense so far? Yes, okay. So now, let us attach several other bangs to this thing. I'm gonna make 8 bangs. I can count, I promise. okay? And I'm gonna connect each one to an outlet of the select. So I connect them, input matches 3, input matches 4, pop, pop. Tiny bit of tedium right here, there we go. And now, if you've connected them correctly, you should have a little sequencer. Little step sequencer with 8 steps. Neat. Does anyone recall the object we used before the break where it would produce a note and then also produce a note off message? Make note. We use make note. By the way, I just want to say this too. If this seems really bizarre and I'm making this look easy, it's because I do this a lot. Like yeah. I spend a good portion of my time in Max. So there's still things I'm learning and still things I'm always doing, things that are new with Max. But if it seems like I'm pulling these out of a hat, just know that I've been doing this for a while. So don't be intimidated by it. Just follow along with me. Okay, make note. And I sometimes liken learning a software or a programming language to practicing an instrument. It's actually like the same process. Yeah. Anyway, so remember that make note is accepting information for pitch, velocity, and duration. That's special. Remember, in MIDI land, that's very special. Because remember last time we had that cacophony of pitches that just kept ringing forever and ever and ever? You know, if we all did that and then left the speakers on at maximum volume, it would probably destroy them after a certain point. They would just fatigue. It would take a long time, but it's possible, right? At certain volumes. So we don't want that to happen. So using the make note, it's going to send the note off after that duration interval. Okay, what am I talking about? Let's do this. Let's set up the make note. I'm going to make 2 integer boxes. That's I. And then I'm going to plug them into velocity and then duration. Those are those cold inlets, the blue ones. The middle one and the far right one. If it's difficult to see those colors for you, that's okay. Just remember it's going to be the one that's in the middle and then to the right. I will say that if an object has inlets, the furthest left will always, try to think if there's an exception to this, it'll almost always be hot. That is red. That means it's sending a bang through it. Anyway, okay, so I locked the patcher. I'm going to set up my velocity. What's the minimum and maximum integer we have for velocity in MIDI 1.0 with 7 bits to express it? 2 to the power 7? Anyone have a calculator? 2 to the power 7? 2 times 2 times 2 times 2, 128. Yes, 128 is our maximum value. Now check it out. I encourage you to do this because, check it out. Is anyone here a code person? Has anyone like done coding? Yeah, a couple people. For those of you who've done coding, isn't it a nightmare when you open up someone's code and there's like no comments and you have to like figure out what the heck is going on? And if they don't know what they're doing, oh no. Well, sometimes that happens to me when I look at students' assignments. So I'm gonna encourage you to use comments in these. Just like any other programming language, Max has comments. Yes, and we don't need to think about them as having like, 2 pound signs or any certain bracketing thing, you just hit the letter C with the patch unlocked, and it makes a semi-transparent text box, and you can type comment. Now, the reason I dig on this so much is that it can help you organize your thoughts when you're starting this kind of process. Because this is super different than writing music in MuseScore. This is super different than using a DAW. And so in many cases, I will put a comment if I'm brainstorming or if I'm trying to think through the problem. The problem here is I need to remember, start the reactor. Okay, remember, my integers are 0 through 127 for velocity. Yep, those are the available numbers. Comment. Duration is measured in milliseconds. Now you might be saying, that's really small down there. I can't really see that in the back of the classroom. And I'd say, you're right. So I'm going to change that. Check it out. Check it out. This is a slight aside, but it's going to be helpful for us. I'll move my face. So in Max, look at this panel over here. We have some very useful tools here. The inspector is one of the coolest things. When I open the inspector, that's the I for inspector. If I click an object and have the inspector open, it's going to show me options for those things. So I'm going to click the comment that I made. You got to unlock the patcher. Click the comment I made, and then go down to font, and I'm going to change the font. I'm going to use a font. What's a good one? Oh, that one's neat. No, none of these are like fun though. That's fun. Got wingdings and webdings. It's just it's for like before there were emojis that were standardized, you had these other things. Yeah. Dude, I like Monaco. Oh man, I like that one. Anyway, and then I can change the size of it and make it really big, so you, in the back of the class, you can see it. Hey, every single object in Max can be manipulated with the inspector. You can change the colors of the buttons. You can change the text of the objects. You can change anything. And that might not seem like a big deal right now, but considering that the piece you're going to be making and the other ones will have to factor in my own usability, then you might want to make adjustments to things. Anyway, so here's another example. I can go down here and I can select all these buttons. Notice how I click and drag, just like we're on our desktop on a computer. I click and drag, and I'm going to change the blink color, the Blink 182 color, to, I don't know, like a salmon. It's salmon now. Now hang on a second. The thing I'm talking about might seem a little bit left field. Like, why does this matter for a sequencer? Oftentimes in Max, if you're creating essentially like a little piece of software, like a dashboard or an instrument that someone can interact with, you may want to consider accessibility. Some folks see colors differently. Some folks can't see at all. Some folks have very limited ability to interact with things. And your ability to change these things is part of that realm of accessibility. And yes, I've made adjustments to patches to make them more accessible to folks. And so it's a good thing to know how to do in a situation like this, because you have a special power over what you're creating that is not always available in a DAW. Often is not available in a DAW, except for light and dark mode. Okay, great, thanks. Or invert colors, oh boy. Okay, anyway, great, cool story, bro. I'll close this out. There's other stuff you can play around with. Hey, I want to say this too. Some of the objects have a lot of parameters that can be adjusted. If you break something, don't worry about it. Just delete it and make a new one fresh. So don't be afraid to change things because you might mess it up, right? You can just delete it and be done with it. Okay, back to the issue at hand. I'm put this down here to help me. Duration measured in, that needs to be bigger. No, I said bigger. Duration measured in milliseconds. I'm gonna do, I don't know, 585 milliseconds, great. With a velocity of, let's say about 100. Sure, perfect. Okay. Now we need the thing that's gonna make the note. What was that called? Note out. Note out. Note out. Okay, how do we connect the make note to the note out to get it to make sounds? Take a look at the inlets and the outlets and the inlets, and then somebody give me a suggestion. P.S. I'm also going to make this object bigger because I feel like it today. Let's make it 36. Boom. Note out. Boom. Has no effect on it. Purely aesthetics. I'm going to change the font, dude. Oh, that's cool. I feel so cool. Yeah. Okay, any suggestions? Plug in. Okay, wait a minute. Which one are we talking about? Wait. I want you to be very specific.
You click on the note out first inlet and you connect it with bottom inlet on make note.
Bottom outlet. Yeah, because the signal is going out here. Yes, so you're absolutely correct. Is there another way to express what you expressed? Thinking about the progression of signal flow? You're absolutely correct. Is there another way to express that? You could say outlet of make note into the inlet of note out. I know it seems like what's the big deal, Dr. Welty? Why does that matter? The way you expressed it is totally fine. I want to express it in this other way, which is just flipping around the order that we did things, because signal flow is super important to me. You might say to yourself, Dr. Welty, I only play acoustic instruments. I don't use any of the amplification nonsense. And I'd be like, bruh, you still have a signal flow. Like of things, of impulse and sound generation. There's still an order of operations that has to occur for the sound impulse to be created. If you blow into a trombone, you absolutely have a signal flow, right? See what I'm saying? Okay. Now, maybe I have an advantage because I'm plugging in pedals and cables and amplifiers all day, but I like to think about this as like the data is going through this system. It's like a river. It is. And so, yeah. Okay, great. And then what else? What else needs to be plugged in? There's not enough data yet. Velocity. It's over here. I'm sorry, I wish I could make that little preview bigger. The velocity goes in here to velocity on the note out. Cool, man. Let's test this before we do anything else. I'm gonna make a message box and I'm gonna put 60 in there and I'm gonna plug it into make note. And then click on, but wait, I need to actually send my audio. You don't have to do this, I have to do this. Send the audio, boop. Do. I didn't plug in the box. What a goose. Give me 1 second. I'm gonna plug that in. Got it. Crestron. And it's gonna power up. Crestron. Oh, I have to send it out here. Yep. I knew that. There it is. Okay, and we're just testing that right now. great. So, that works. We have sound. Now, for each one of these impulses, we're going to put in some kind of integer. So I'm going to create 8 integer boxes. That's right. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to organize them in such a way that I can see where they're going. 3, 4, 5, 6. Don't worry, we're going to play around with other ways to goof around with this data in a second. It's going to be a fun time. Okay, now I'm going to plug each one of these bangs into the integer. Plug them in like this. Doop-a-doop-a-doo. Remember to unlock your patcher if you're trying to plug things in. Okay, they're all plugged in. And then I'm going to send each one into make note. They're all going to the pitch input because we already have the velocity and the duration programmed in the other integer boxes. Amen. Okay. Oh, man. All right. All right. And then, yeah, they're all going through. Great. Now no sound is coming out because they're all 0. Well, yeah, man. So I'm just going to put random numbers in here. And turn down my sound so I'm not super annoying. A little bit annoying. Okay, our very simple sequencer should be working. So remember, the reason we're hearing that vicious glissando is because when you change the integer value of an integer box, it sends a bang for every change that occurs. Okay, great. So we have our device. We've made a sequencer. Okay. So this is the absolute simplest. Is it the simplest? Well, it's the simplest way that we've covered in our class so far. But there are other ways to represent data like this. I want to show us some of the other ways to represent and manipulate integers. And then, because these MIDI sounds are just so boring, we're going to send this device out to another kind of device. I'll explain in a second. Okay, anyway. Just enjoying this for a second. This is like the butterfly meme. Is this modern music? So, okay. Let me move this over here. All right, so let's turn those off. We'll have ample time to play. Okay. Great. So we're gonna hang on to this device in this thing. I'm gonna zoom out a little bit, and I want us to talk about some other ways to represent numerical data. Okay, hold on. For a second. So check this out. Don't worry, I'll turn it back on in a second. Don't worry. We'll have plenty of time to play around. Now, let's make an object called multi-slider. I don't know about you, but that makes me really hungry. Yeah. I can never just have one slider. I have to have multi. So multi-slider, and I made it bigger by dragging on the corners. You know, you can make it whatever size you want. And we need to open the inspector because we have to do something with this. How do you do that? You click on the object and click on this little eye over here. Click on this and it opens up the inspector and you can change parameters. Now pay attention. Follow with me. This part's really important. Huh? I made it. It's you make an object. So that's the hotkey N, and then type in multi-slider, and it makes a multi-slider. Okay. When you have the inspector open, you're gonna go down. Where is it? Where is it? Why can't I? Oh, I'm sorry. I'm thinking of a different object. Forget it. I'm looking for something that's not going to be here. Go over here. Sliders. Number of sliders. What's a reasonable number of sliders we should have? 10? Okay. 10. And what does range mean? How high and low it goes. Yes, yes, yes. You're correct. Keep going with that idea. It's the what's the right word? The ambitus. It's what it will output. So I mean, it actually could be. It could be integers that represent or float values that represent frequency. It could be theoretically, but we're still in MIDI land for right now. We're still in MIDI land. So I'm gonna put range is how about 0? And how about 127? Those are separated by a space and there is no dot, no decimal, no floating point after those numbers. I think it'll still put that. It'll still put that. Okay. Now, let me explain that again. I made my multi-slider. I opened the inspector. I went down to the bottom of the inspector window. Scroll down there, and I changed the number of sliders to some reasonable number. Could you make it 1,000? Yes. Yeah, you could. But I just did 10. We had a good suggestion for 10, and then this is important. I changed the range from 0. It was -1 float value to +1 float value, and I changed it to 0 to 127. Okay, the next thing I did is I went down to sliders output values and I changed it from floating point to integer. I'm gonna say that again. The very last thing in the inspector box is sliders output values to integer. Because MIDI doesn't want any of your like float business, doesn't want it. It just wants integers. Can you change the slider style? Yeah. Go ahead. Do whatever you want right there. I made it a bar, and let me see. I'm not seeing the thing I'm looking for at this moment. Where is it? I'm also gonna put continuous data output. Where's my candy cane dog? You can change the slider spacing if you want to. Oh, here it is. I'm a silly goose. Alternating candy cane has no effect on it, has no effect on how it behaves. It just means you can change the colors and have cool colors. Yay! Question?
I'm adjusting everything when nothing's showing on the multi-slider. I didn't see any lines. I couldn't adjust it to bar like it's not showing.
Yeah, it won't do anything until you lock the patcher and then go click on it. And then you'll see stuff move around. Woo! Okay, so I'm having too much fun. I'm just clicking and dragging. Clicking and dragging. Question.
What was the range number you said?
The which number?
The range?
Oh, the range? 0 to 127. And make sure at the bottom, you go down at the very bottom, and you're going to switch it to integer from floating point to send values as integers. You guys are doing great following along, by the way. Just want to say, because this gets a little gnarly sometimes. Okay. So far, so good. Maybe. Okay, now, oh wait, just a second. Okay, so, want to make sure everyone's in a cool place. What's up? Yeah. Okay. Let me see. I'm gonna take my coffee with me. Okay, turned. So, great. Okay, so it's spitting out values we can't see. So we're gonna make a message box. Hit M for message, and we're gonna connect. Now this is gonna seem a little strange. It's gonna seem a little weird. We actually need to connect the left outlet to the hot and cold inlets of the message box. And when you do that, I'm going to zoom in so you can see I've connected it to both for reasons I will discuss in a second. And then when I do that, it's showing me the numbers that I'm outputting. And they're changing continuously because I'm just clicking and dragging.
What box did you press to get that?
M for message box. Yep. That's what this guy is. And then to get those values as a list, as a Franz list, I'm plugging in the far left outlet into the hot inlet and cold inlet of the message box for reasons we'll talk about in a second. And then when I click and drag, it updates the values. Mine are updating in real time because I have continuous data output enabled. But you could also do it without that and still work fine. Just mine's going to behave a little differently. So, wait, can we see where we're going right now? Where is this going? We have a way of manipulating and creating a set of integers that are a list. It's a list. Now, yes, we're going to use these to make notes. That's right. This is another way of showing this information. So now, okay, how do we get this list to become separate numbers? There's a number of ways to do this. We're not going to use regex. We're not going to get too far into the weeds. We're actually going to use an object called unpack. Unpack. And if you read the text, it's really small. I'm sorry. It says break a list into individual messages. Because the multi-slider is sending a list of integers, and then we need to separate all of them because we need each one individually. If you send a bunch of these integers to a MIDI device, it's going to just be like, it's just going to interpret the first one and be like, okay, what's this other stuff? I don't know, whatever. So unpack, but wait, there's more. With unpack, let's do this. Let's go and look at the unpack help together. How did I do that? I either right-clicked if I have a mouse, or I double-click on a Mac touchpad, and I go open unpack help. Now this is important If any of you have been in coding land and someone on Stack Overflow is very unhelpful and they're like, read the documentation, this is like the equivalent to that. Notice the arguments. Okay, so this is just a sample patcher that's going to break our list into elements. And if I click on this one, I have the integer 5. I have these first digits of pi, and then I have the symbol, the string, which was high. And down here, I suppose we're trying to suggest the number 1 and perhaps Euler's number, another irrational number. I think I don't have enough digits to know, but if they put pi up here, they probably put Euler's there. I don't know. Anyway, and then low. Sure, great. Let me back up. These, remember with select how the arguments, it was waiting for a symbol. And it wanted the symbol 1 or the string anything. This one's a little different. This one is either listening for 0 as a what? What is 0 in our land? What kind of object is 0? It's an integer. What kind of object is 0 with a dot? Starts with an F. It's a float. Yes. And what kind of object do you think they mean by sim here? Symbol. Symbol. Which I suppose is always the same as string. I'm trying to think of a reason why it wouldn't be. Sorry, question? So it's interpreting that. See, in my world, I would call that a string because it's letters, right? But this one wants to hear sim. Okay, great. So knowing that, what kind of argument do you think we need for our patch to parse these integers here? Wait, let's look at the help again. Let's look at the help. We're on the cusp. How do we represent an integer in unpacks arguments? It's the first thing, the first argument. What's the first argument? It's the number 0, which we said is a integer. Yes. Whoa. What? Ah. Okay, good. So that means we just have to put 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whee! Because the list has 10 elements and all the elements are integers. I'm going to say that again. Unpack arguments are 10 zeros only because the incoming list that we need to parse is a list of 10 integers. Okay, plug this in to unpack. And now let's create 10 integer boxes. Yay! And then plug them all in. Yay! Okay, 1, 2, 3, 4. Okay. Okay. Okay, great. Now, check this out. As you're doing it, if you plugged everything correctly, when you change these values, it's now parsing the data properly, and each one of these integer boxes is giving us something that we need. I have a question. Go ahead and finish what you're doing, plugging stuff in, then I'll ask my question. Why do you think we need 2 cables from the multi-slider to this message box? What happens if I get rid of this one, the hot inlet? It updates the message box, but it doesn't update the integers. Because only the hot inlet sends the bang impulse through the object. I'm going to say it again. Only the hot inlet accepts the bang from the object to go through the system. So when I put it into the cold inlet, it was updating the message box, but it wasn't sending an impulse to then go to the unpack. But now, this way, the signal flow, the impulse is going through the system to update those things. And you might say to yourself, Dr. Welty, this is like algebra class. When am I going to use this? And I'd be like, bruh, like, this is just like the same thing you encounter in a DAW. When you're routing things and busing things, by the way, you have to be thinking of signal flow. Okay, cool. Neat. Okay, so then from here, guys, it's the same deal I have here, right? I can send that data through here. And then I can go over here and I can make my toggle, and I can make my metro that goes really fast, and then I can make my bang, and then I can bang, that's 2 bangs. I can do that. There actually is an object called MUSI, which sends like a bunch of bangs. Kind of funny, a little bit outdated. Is it in poor taste? I don't know. That's up to you. And so I can use the rest of this information to send that stuff through there. This gives us a way to basically compose by creating these orders of things. Does this make sense so far? You're not limited to 10 sliders, and you're not limited to 10 integers. You could put as many as you want to. Just got to connect some things, and it's fine. Is that a question?
Yeah. Are you saying we could connect this data into the thing that we just made, right?
Yes, we could. Yeah, we could.
How do we do that?
Okay, well, we can go over here. Yeah, let's, how exactly do I want to connect it? I'm going to make it slightly different. I'm going to make it just a little bit different for us. Where I'm going to send, I'm going to move all of these guys down. Where is my mind? Where is my brain? It's gone. So let me make another. 1 through 10. Select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So I'm just creating the same device I had before that's going to move things into sequence. Nothing new here. I just made 10 because we have 10, and I want to use all of them, right? Boom, 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 boom. I'll put another one over here just so I know it's counting correctly. Yep. Okay. Now this is going to seem a little strange. I have this as a kind of auxiliary, if you will. What I'm going to do, I don't want to do that. I'll do it this way. It's not going to look. I'm doing this, I'm writing all these out so that you can see the process, but also it's a type of debugging. Like I'm preparing for something to go wrong, and I'm representing all the steps. Do I need to put all these bangs in here? Actually, no. I could actually just send the select impulse straight through to the integer boxes. But I'm doing this because if something goes wrong, I want to identify what's going wrong. So I'm actually just recreating the exact thing I made earlier before your very eyes. And yes, there will always be one left over because that's the one bang if input doesn't match. And then I send these through sequentially into my integer boxes because those are the things I'm sending through to the system in order. Boo, boo, doo, boo, doo, boo, boo, doo, boo, 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 boo. There's time to talk about one more thing, two more things actually. And I turn it on, and okay, it's going through, and we don't see or hear anything because I need to make note. You know what? I'm just gonna use the same one. Lazy time. I'm gonna bring these over. And I'm just gonna plug these, boop, in here. And yeah, mine's not making any sound because remember I turned the system down. The system is down. Wonderful. Ah! I'm sorry, guys. Turn myself down. Yeah. I'm gonna turn it down. I'm gonna turn myself down while I make changes here. Okay, so somewhere along the lines, do you guys ever see the video where that guy's like, he's playing around in Ableton or something, and he's like, yeah, bro, you don't need music theory, you just like put notes in, and then like, so listen, I know this sounds a little like that, and I don't want to suggest like, hey, check this out, I'm gonna make a sick beat with this. This is something a little different, and I'm teaching you this, by the way, not because you're gonna make hit records with this type of device necessarily, but because it's going to help us learn about how to make objects, signal flow, etc. So just keep that in mind. Sounds great. Take the band on tour. Okay, I'm gonna turn this down just so we don't all collectively go insane. Okay, now, cool. Well, that's how we use the multi-slider to represent integers and then send those integers through. But wait, there's more. Check this out. Okay. Get ready. New object called live.grid. Sick. Live.grid. Okay, I'm gonna make a couple changes to grid. There's a lot to do with grid. You can do a lot. I'm gonna make this as simple as possible so that we can actually like literally use it like we were operating a different type of sequencer. So what I'm gonna do is I made live.grid, and then I opened the inspector, and I'm gonna make number of columns, let's call it 8, and number of rows, I'm gonna make it 1. I said 1. 1. I got it. Why are you fighting with me? It like woke up and chose violence. No, it's because display directions panel. Boom. Got rid of the directions panel. And now I don't want to freeze anything. Go. Why are you fighting with me? Give me 1 second, y'all. Oh, I'm a silly goose. I forgot to enable one thing. Okay, so check it out. When you make the live.grid, I got ahead of myself. You want to turn on matrix mode? The matrix. The matrix. Number of columns becomes 8. Number of rows becomes 1. And then you get this looking thing. And you can change the colors and stuff too if you want to. Now, we're running low on time. I'm gonna go a little quick. You can review the film later today, if you wish. So, make my same device as before. Toggle, Metro, 500. Counter, 1, 8. Check that out. The way it's programmed, it'll automatically start reading through the steps. Now, I chose to make one row for now because I want it to send a very distinct piece of data. When this goes through, it's going to be sending a 1 or a 0 as the counter goes through. So notice that the blocks I've enabled will spit out a 1, and the blocks I have not enabled spit out a 0. P.S. Just to be sure, I made my live grid look like this by scrolling down and going to matrix mode, then changing number of columns and number of rows to 8 and then 1. And then also, for now, I got rid of the display directions panel. I turned that off. Even though that thing is super cool, but we're not going to use it right now. There would be no shame whatsoever in reviewing this part of the film just because we're running short on time. There's so much to talk about. Now, we need to set up a situation where it's checking if it's a 1 or a 0 coming through the system. Are there questions right now? I hear sighing. Are there questions right now? Huh? If this is confusing, I understand. Come to office hours. I'm gonna wrap this up for the video that you can review and say if get ready. If $ integer 1 then bang. If $ integer 1 then bang. That means it's checking, and if it sees a 1, like our select object, if it sees a 1, it sends a bang. Let's test it. Yeah, it's banging at the same rate that we have a lit block. So from there, you can imagine, now to send that through. Now to send that through. Integer. Boop, 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 boop. And okay, so hang on. Whoa. There's a lot of information here. For your assignment, hang on. I love your sounds, but for your assignment, check this out. It's a bit open-ended. So, you don't have to use all 3 of these methods. You could use one of these methods. You could use 2 of them, right? You could, yeah. But what I want you to do is to make a max patch that I am going to interact with. It can be like a Rube Goldberg kind of device where I click a button and then it creates something, right? But I want to remind you that one of the things that Max is really good at is creating kind of stochastic music. And so an object that's going to be a friend to you is random. Random with an argument of 128, where you can make this thing spit out random numbers. So when I say create a piece with this, for now, I want you to use the MIDI, just the lame MIDI for now. The next assignment we do will be using VSTs with our MIDI devices to create something a bit more interesting. So right now, it might sound a little, maybe dorky is too strong a word, but with the sounds that they're not going to be great for right now. But we're actually playing with managing data and routing numbers and routing information more than we're playing with actually like making music strictly in the sense that we tend to think about it. Okay, does that make sense? This patch will be available. Can you copy and paste from it? Yeah, you could. But I ask you to do it carefully and make sure you're understanding how the little things are working, the objects are working. Okay, brutal. Are there any questions? Now what I want to say is, if you make a little piece where I click on a toggle button and it starts playing an 8-step sequence, okay, well, sure. Yeah, I'll accept it and I'll grade it. But I think you can be a little more creative than that. So I would encourage you to be a little more creative than that. You're also not limited to one sequencer. How many channels does MIDI 1.0 have? 16. 16. Remember, 10 is dedicated to percussion. But the other ones can be anything you want it to be. It can be any way you want it. That's the way you need it. So we can also do PGM out. Remember PGM out? Do you remember? PGM out, integer. And then I change that, and it's going to change the patch. It's going to change the sound. Now, by the way, if you were to use, check this out, one more thing I want to add for your creative brains. Don't go yet. If I say note out 1, that's MIDI channel 1. Note out 2, that's MIDI channel 2. Note out 3, etc. Notice I was getting this thick bass drum sound over here because I was using channel 10, which is dedicated to percussions. If you make a different channel and you want to change your program, your PGM out argument has to match the MIDI channel argument on note out. That way, if I change this one, whatever's plugged into this note out, the sound will be different. But if I make a new PGM out 2, this one is going to affect note out 2, even though they're not connected. I bet you'll have questions. Remember, I'm not expecting anything that's like necessarily perfect or astounding. We're just getting our feet wet with the software. And I promise you, it'll be more interesting after this assignment. Okay, that's all I have for today. I hope to see you at office hours if you have questions. You can also just come by and say hello. Whatever. I'm gonna go get some more coffee and then I'll be back for office hours. Okay. Ciao.